The Lynx, a new helicopter designed and built by Westland in collaboration with Aerospatiale, first flew on Sunday, March the 21st, 1971, and 2 weeks later made its debut to press and television, when leading aviation journalists came to Westland at Yeovil to have their first look at Lynx. High performance, multi-role capability, robustness, reliability and easy maintenance are the key design features of the Lynx. Two variants are under construction, the Army Lynx, which has an all-up weight of 8,000 pounds, and the Sea Lynx, which will operate with the Navy from small ships at higher all-up weights. The spacious, unobstructed cabin of the Lynx is ideally suited to the carriage of freight, to transporting up to 11 troops, and to allow easy conversion to the casualty evacuation role using 3 standard stretchers. The pilot's task is reduced by the simple cockpit layout and the self-contained Doppler navigation system. The naval variant carries new and advanced radar for use in the surface search role. Engine controls, rotor brake, fuel and electrical management systems are carried in the roof panel. Controls for auto-stabilization, automatic flight, radio and navigation aid systems are on a central console. Intensive wind tunnel testing of the helicopter's aerodynamics was carried out using a 1/5 scale model. The BS-360 gas turbines, which powered the Lynx through the main gearbox, were developed and tested at the Rolls-Royce Small Engines Division. A simple 2-stage gearbox with low drag profile embodies conformal gears developed and tested by Westland, which give considerable weight and size reductions and improved performance. The non-articulating rotor head uses flexible titanium elements to eliminate flapping and drag hinges. Comprehensive fatigue test programs were carried out on each of the flexible components before testing the complete head in monoblock form. Advantages of the new rotor head are mechanical simplicity and improved in-service life. It also simplifies maintenance and reduces its costs, and results in lower control loads and improved performance, particularly speed. The development aircraft have separate flapping elements bolted to a central block. Production rotor heads will be made in one piece. A bolted head assembly was fitted to the first airframe for ground testing. A rotor head representative of the new configuration was used on a Scout helicopter to accelerate development and to substantiate the forecasts of performance and vibration characteristics. Over 50 hours test flying, including trials by the British government test establishment at Bedford, fully confirmed the design predictions. In particular, control response was rapid and precise throughout the Scout speed envelope. The first Lynx airframe and rotor system was used entirely for ground testing, so that true structural stiffness and response data could be established before the first flight of the prototype aircraft. A second airframe was used for checking the effect of the dynamic forces of the rotor blades transmitted through the rotor head to the aircraft structure. "12 development aircraft will be used in an overall trials program covering over 1,200 hours flying. Production of these machines is already well advanced at Yeovil. The flight program is backed by a wide range of system and equipment ground test rigs. (0001), the first flying aircraft, was completed in early March 1971. first rollout marked the completion of hundreds of hours of early testing of the wide range of advanced technology used on the Lynx. Over 80 hours of ground running had been completed with the rotor rig aircraft before the first flight. Aircraft 01 then completed a program of engine and system checks in preparation for the first liftoff. With the successful completion of these tests, the Lynx is towed out to its flight pad. With a heavy load of test equipment and 3 air crew, the helicopter is within 100 pounds of its maximum design takeoff weight as it lifts off on its first flight. Its 2 Rolls-Royce BS360 engines are designed to develop a total of 1,800 shaft horsepower, giving a generous power reserve to meet hot and high conditions and to ensure full engine out performance. Flown by Westland's chief test pilot, Ron Gillatley, the Lynx made a 15-minute maiden flight, achieved without the assistance of the auto-stabilization system. No fundamental problems were encountered, despite the entirely new concepts and the many new and advanced engineering features that are incorporated in the helicopter. A second flight followed on the same day, with a rapid exploration of the helicopter's flight characteristics. The Lynx, when fully developed, will be capable of a continuous cruising speed of 160 knots at maximum all-up weight. After 20 sorties, altitudes up to 6,000 feet and speeds of over 150 knots in level flight and turbulent conditions were achieved. The aircraft was also flight checked at 250 pounds above its normal gross weight. Together with the Puma and the Gazelle, the Lynx was selected by the British and French governments to form a part of a package deal arranged to exploit the joint development, production and marketing resources of Westland and Aerospatiale. The multi-role Lynx sets new standards of performance in all weather conditions. The use of advanced helicopter technology gives reliability, high structural integrity and ease of maintenance. The Lynx, a next-generation helicopter designed to cover the broad spectrum of Anglo-French requirements, both in land bases and maritime roles. It sets new levels of mission capability and performance in all operating environments.